Um, Last Monday we covered the equilibrium constant, and we talked about equilibrium constant is the ratio between products over the reactant concentrations raised to their corresponding number of moles. And here we have two examples in the PowerPoint I would like to discuss. This is the first example. And there, keep in mind that we have anytime I have the subscript G means gas, that's we are considering it. Then we have aqueous, those are two are considered. So now the S solids, the solid here, and the L liquid here, they are not considered in the equilibrium constant. What they call it? Equilibrium constant expression. So if I have this reaction, I want to set up the K equilibrium for this reaction here. Will be K equilibrium, as you see in the product is here, gas, so we have to consider it. So that's the gas, and number of mole is 1, understood, this 1 is there, so we don't write the 1. So, and then you have H2O here, gas, you have to consider H2O. If it's liquid, then it's not. Over 1 is understood, not written as SO3, sulfur trioxide, over 1. The one's understood, not written, so you don't need it. That's number of moles. Now you set up this, and then you put the concentration of each of those reactants and the products. H2O here, you replace it with the amount of H2O, which is 0.480. SO3, you replace it with SO3, is 0.400, correct? And those are the reactants. And the product is H2SO4, sulfuric acid, and sulfuric acid concentration is 0.6. So you have 0.6 products divided by product of 0.4, the H2O, multiplied by 0.480 for SO3. So, and then you calculate, it came up the K equilibrium to be 3.13. So this is greater than 1, correct? So it means that the chemical equilibrium favors the product. So the reactant goes to completion. So this is here, the fact that the value here greater than 1, you'll say the chemical equilibrium favors what? Favors the products. And the conclusion out of this, chemical reaction goes to completion. So that's what it's really saying. So let's look at the second example. So the second example here, everybody has this. Let's take this one out. Again, you will have the opportunity to go to iCollege and find the YouTube of this lecture. So let's take this one out, and we are taking the second example. Now the second example is tricky. Why? Because it does have a solid. So this is the reaction here. We said products over the reactants. Those are the products, and this is power 2 exponent. The number of mole will be as exponent 2, correct? Now, this is solid. You have to watch. This is solid, so you don't consider it in the K equilibrium. So the K equilibrium will be HCl square. This is because of 2 here, multiplied by the POCl3 concentration, both of those multiplication. This multiplication here, divided by H2O gas. How about this PaCl5? PaCl5 is a solid, so therefore we are not consider this one. This one is out of consideration. It's not part of the. It's not part of the what? Part of the expression of the equilibrium constant. Then you plug in all the numbers. Again, you get the value is 1.4 is greater than 1. Your conclusion of this is favors the products. The chemical equilibrium favors the products. Correct? That's number one. Number one. Number two, chemical reaction goes to completion. Goes to completion. So whenever is greater than 1 is that's the case. Less then it will favors the reactant, correct? And it's barely is really happening. Chemical reaction barely had started, correct? So that's the way it is. So that will conclude the calculation first chemical equilibrium constant expression and its calculation. Now the last topic, which is a very important topic, which is really coming in the lab, will come in the lecture, and will come in the last of your last quiz and last exam number 4, quiz number 4. So let's take this one out, and let's look at the this one. We have this one here last week, correct? We talked about the chemical equilibrium last experiment. So what it says here, it says that if I have a reaction, I'll express this the whole thing in a very simple way. I have a chemical reaction, okay? This chemical reaction in equilibrium means as soon as the products are producing the products, the reactants are producing the products are decomposed and bringing back the reactants back. So it goes back and forth between reactants, producing products, decomposing, producing back the reactants, products, reactants, and so on. So it's an equilibrium. However, this situation will change if I will alter or change the chemical equilibrium by adding some of the external condition from outside. When I start playing around this chemical equilibrium, adding some stuff to it, dropping some stuff in this chemical reaction, the chemical equilibrium will reject it, will not really like it. You say, no, I want to go back to my status where the chemical equilibrium was what was held, correct? So in order to do this, the chemical reaction will go back and forth and will examine which side of the chemical reaction equilibrium, left or right, reactant side or product side, has the least stress coming from this external throwing away a condition that's not a part of the chemical equilibrium to begin with. So it will adjust itself to adjust itself to the side, reactant side or product side with the least amount of stress. Are you following me here? So that's what the chemical equilibrium is. Chemical equilibrium is reactant will produce a product will decompose, go back, producing for you reactants. However, when you are starting intervening by adding some stuff inside the chemical equilibrium will not like it, wants to go back to its original status. So it has to adjust itself back and forth, going to the side with the least stress. Now, what those are conditions? Those are the conditions are here, and so I'm not writing the definition. I told you the definition is. So, Le Chatelain principle. The chemical equilibrium is in equilibrium as long as there is no external condition is affecting it. As soon as there is external condition is affecting this chemical equilibrium, the chemical equilibrium will shift to the side which least stress, to release the stress, to regain its status back to the chemical equilibrium. And those conditions are here. If I start changing the concentration of the reactants, correct, that will affect, that's a condition I can affect this chemical equilibrium. Changing the heat of the reaction by heating or cooling, changing the volume of this reaction system, changing the pressure of the system, adding a catalyst. All those conditions I can play around them, and then I will affect this chemical equilibrium. The chemical equilibrium will take those conditions in, readjust itself, and it will go to the side with the least stress, so it will regain its status back again to chemical equilibrium, correct? So those are the conditions here. Those are conditions here, write them here, conditions are affecting chemical equilibrium. And this is the principle of Le Chatelier. Okay, so let's look at some of the examples that will give us the idea what's going on. Okay, guys, so that's what it says here, definition, and those the conditions can affect the chemical equilibrium. Can I take this one out? I'm taking this one out, and let's see what those conditions are, and I'm taking those here. This reaction here, look at this. This reaction here, I have the Kb is given to me is 0.108. 0.08 what? Less than 1, correct? Less than 1. What this means here with this value, that's equilibrium favors what? Chemical equilibrium. Somebody will tell me? Less than 1 favors what? Favors what? Reactants, correct? Because less than 1, reactants, 1. Number 2, the reaction had not started yet, or the reaction has not. Reaction is barely progressing. Not started yet, so not started or has started yet. Okay, guys, so whenever I put this one here, this one is out. Why? It's solid. It's not part of the consideration. So I set up this. Look at this. Those are the products. Will come here. I divide them with this solid here, ammonium hydrogen sulfate, or hydrogen sulfide, yeah. So this one is solid, correct? Yeah, this one is, or yeah, ammonium. Yeah, so this is solid, correct? This is solid here. So because solid, so you don't consider it is out. So this is the only one. Kb is this, and it's less than 1. Then it favors the reactant side, and the reactions have barely started or progressing. Correct? So we discard here, say we discard this solid stuff. So now we can look at the Le Chatelier principle by affecting some stuff here, by adding some stuff and shifting the equilibrium back and forth. Okay, I can add ammonium, I can add H2S, and see what the reaction will go as a reactant amount here. Let me take this one here out. Already has it. Okay. Let's go here and look at this one here when the heat affecting the chemical. This reaction, you did it last week, I think, in the lab, and my Monday lab did it this week, Monday. And this is about, remember the 2 test tube you came in with me, 1 and 2, correct? Each test tube has a cobalt tetrachloride, nitrate first. You started with cobalt nitrate. It is. You started cobalt nitrate, NO3, 2, and both of them were pink, correct? Pink. Then I added concentrated HCl to both of them, concentrated HCl to number 2. So this is pink. Nothing is added. Number 2 is added. So it is nothing is added here. But number two here we added concentrated HCl. What's happened when I added HCl? According to the reaction, HCl will come and react with cobalt nitrate, forcing that's from the HCl here. So you add one HCl here, HCl, you have the chloride here already to begin with. So where the shift, this arm will be more is what? More stressed, and it turns out to be what? This is blue, and this is pink, correct? So now if you add HCl, the test tube number 2, test tube 2 turns what? Blue. According to whatever we have here, look at this, correct? So here it is. So we added this came at the beginning pink and then turns blue. So this is pink, this is blue. You added HCl. The HCl has what? Will dissociate to give you H plus Cl minus. Do you have a common reactant there with Cl minus? Yes. Cl minus here will add itself to the Cl there. So this arm of the balance of the reactants will be more stress, more weight of this side. So the shift will be which way to release the stress, some of the weight, some of the chemical substance to act to produce you the blue one of the cobalt tetrachloride. Now, when we start heating both of them, nothing changed. The pink remains pink, nothing inside it. The blue remains blue. So when I heat, the heat is, if I add the heat here, the heat is in the left, correct? That's an endothermic reaction. So the heat is in the left, so the shift will be, the blue remains blue. But when I start cooling, put them in the ice, both of them, 1 and 2, correct? That's blue. And this is pink. And this is ice. Now what's happened is the pink has nothing inside it, no shift, no nothing. It remains pink. But the blue, since we are removing the heat, this arm is missing something. This reactant side is missing something. So the shift will be which way? To compensate for the heat lost. So the shift will be to the left, and the blue number 2 will be fainting. If we keep it overnight, it will be what? It will turn pink. But we did not stay for a long time. We said that the blue will have a fainting blue color or a pinkish color, very faint blue color. So the blue color will change if you leave it for a long time in the ice. It will turn pink. So the shift to the left. So, and this is just an example what we did in the lab. So this is an endothermic reaction. Endothermic reaction. So, any question about the experiment we did? Okay, so, and I will go for the worksheet. We'll see more examples of this. So, here is this changing the volume. Now, you have to watch when you change the volume of a chemical reaction. We have Boyle's law. Whoever went to the Boyle's law extra credit get the idea. What's Boyle's law? Somebody still remembers? Boyle's law. The volume is indirect proportional to the pressure. Volume of any gas is indirect proportional to its what? Pressure. So if I increase the volume, the pressure will decrease. If I increase the pressure, the volume will decrease, and vice versa. So one goes up, the others goes what? Down. They are not going in the same wavelength. One is going up, the other one will go down. Opposite direction. If you increase the volume, the pressure will go down. If you decrease the volume, the pressure will go up. So in this case here, because this indirect proportional, so we go by the number of moles. We can't calculate number of moles. The heat has no number of moles. Here I have 4, here I have 1. So the sum of this is 5 moles. and here I have 1, and 6, I have how many? 7 moles. Now, if I increase the pressure, so here it is, put this here. Increase the pressure, meaning decreasing the volume, correct? So the shift will be which way of the chemical reaction? To the least number of moles, to the least number of moles. Where's the least number of moles? 5 moles, to the left, reactant side, to the left, to the left. If I decrease the pressure, meaning I increase the volume, then the shift will be shift to the most number of moles. To where? To the right. Okay, guys, so that's what it says when it comes to changing the volume and the pressure. Okay, guys, so that's what it says about changing the volume and the pressure of the chemical equilibrium. So can I take this one out? We'll see some examples. The examples are very important. Then I'll show you the method, so you can use the method of the balance method, so it's easier to follow this method here. So that's what we say. Changing the pressure, you increase the pressure, the volume will go down, then it will go to the least number of moles, the side of the least number of moles. You decrease the pressure, the volume will go up, it will go to the most number of moles. So this is, and the last one is the effect of catalyst. Well, the catalyst is what? The chemical equilibrium. What we said about chemical equilibrium, the catalyst is speeding up the rate of reaction. However, chemical reaction has nothing of increase. The forward rate of reaction has to equal the reverse rate of the reaction. So the catalyst has nothing to say with the chemical equilibrium. It does speed up the rate of the reaction, but in chemical equilibrium, we have nothing to do with the rates, speeding up or slowing down. Now, we have the rate of the reactants producing the product has to be the same rate as decomposing those products, producing back those reactants. Forward rate of reaction equal reverse rate of reaction. So it has nothing to do with speeding up or slowing down the reaction. So the catalyst here has no effect. So the catalyst has, adding catalyst here does not change, meaning catalyst, adding catalyst to chemical equilibrium will have no effect. Okay, guys, now we have finished chapter 8. Let's do for some, so catalyst has nothing to say. So let's do this one here is, let's do some chemical equilibrium. Now, let's do first of all those, I'll do number 1 is the answer is there, but those are just to go over the chemical equilibrium constant. Chemical equilibrium constant. So for those reactions, let's go and look at the chemical equilibrium constant. So the first one here, the main thing is you look at the subscript here, if they are gas or aqueous. Gas, gas, gas. So you have to consider all of those, number 1. You have to consider all of those. And this is A here. So it will be products over what? Over reactants. Products over the reactants. So you have oxygen and NO2. Those are products over the reactants, ozone and nitrogen monoxide. So this is K equilibrium. A. Look at the B here. Look at the B. We have to watch all the time, watching for the, whether it's gas, okay, considered, gas considered, gas considered. So all of them are considered. The B will be K equilibrium equal to CO2. We have 2 here, so it has to be appear as exponent, correct? And O O2 oxygen is here, but SO, carbon monoxide, has 2 in front. It will appear as 2 here. Okay, guys? Now, let's look for C. C, we have a problem with C, correct? Somebody will tell me? That's, I'll do it in another color so you can follow me here. So that's the problem, is liquid. So what? Discard. That's liquid. This is solid, correct? Discard. The only thing left with gas or aqueous is this. Remember, we are considering aqueous, AQ, or gas, or gases, G. L, S, liquid, and solid. When it comes to those are discarded. It's not part of it. So what will be then? What K equilibrium here equal to what? This one, only this, correct? See how nice? That's correct. That's correct. And the last one here, this is gas, okay? This is gas. All of them gases, we have to consider all of them, and there will be you have to watch for oxygen. This oxygen, there, the product. Hydrogen has 2 moles, so hydrogen will come to 2 moles there. The product over the reactant, and the reactant is gas, but it has 2 moles, so the 2 will appear here. Correct, guys? This is how to show. I want to show you how to set up chemical equilibrium. Is it coming in the final exam? Yes. It is coming in the next quiz and exam? Yes. This is very important to know, to set up chemical equilibrium, and they might just, trick you by adding liquids or solids. And if you forget about this, you will include them in the expression, and that will be wrong. That will be absolutely wrong. So liquids, like here we have example, and solids are not part of the expression of chemical equilibrium. Okay, guys? So can I take this one out? Everybody has it? Everybody has it? Okay, so let's take it out. Okay, and then let's do second one. Here's the second one, and I want this answer in multiple choices. Let's make it right here. So we have a reaction here. First of all, you have to make it with correct yes or no if they are considered. This is gas, correct. This is gas, correct. Gas, gas. So all of them are considered. So, and therefore I can here for myself, K equilibrium will be the product, CS2 multiplied by hydrogen. Now hydrogen is what? 4, so it will be what? Okay, correct. And this is methane, CH4. And this is 2, correct? That will be H2S raised to 2. So this is not asked, but I would like to have it. Now the question is, what will happen if I decrease the concentration of dihydrogen sulfide? This is dihydrogen sulfide. This is the reactant. If I want to decrease the amount of it. So let's do this one here, and let's take a snapshot of this. Can I take this one out? I'll take a snapshot of it. Everybody has it? Everybody has it? Okay, let's take this one here, and then take snapshot of this snipping tool. Snipping tool is my best friend. I use it heavily to get, as I said, it's free. Long time we have to buy it, close to $50. So copy, and I'm pasting this. So now that's very good. We did a K equilibrium constant. Now, what I will do here, I'll put myself a very nice, we did this one in the lab, I think. I'll put a balance here. Very nice balance. Okay. I'm not an artist, correct? So I apologize. My apology, not being an artist. I was an artist, but I let it go. So, but anyway, so I have to visualize each reactant and products as what? As weights. So I have here two weights. This is CH4 and this is H2S. This is another weight, CS2. This is another weight, 4 hydrogens. So those are weights. So you can put top of the weight here, top of the weight. Those are weights, correct? Now, I'm decreasing the concentration of dihydrogen sulfide. So decreasing the concentration, meaning I can say I'm removing this one here. I'm removing this one here out. So what will happen to this arm of the balance? Will go up or will go down? Will be lighter or heavier? Will be lighter, so it will go up. Lighter, correct? And this arm will be what? Heavier. Go down. So in order to readjust itself, this equilibrium, the reaction, some of the weight has to be given to what? To the left. So the shift will be shift to the left. Correct? It says this because this is overweight than the arm. This is right, my right arm or the right arm of the balance. This is left arm of the balance. And here is the counter reading whatever it reads. Correct? So shift to the left. Now asking ourselves what evidence you will see or hear or smell. Well, that's very easy. H2S, what we call this one here? Smell. H2S called what? Here it is, make yourself in your hand in your nose. Farting gas. Whoever is farting, animal, birds, humans, has to get this one out. It smells very bad. Especially the animal called skunk. Heard about skunk? Saw it? Yeah, when it's farting and putting all these chemicals, with all the mercaptan and all the H2S, stick in your clothing, and liquid mercaptan with H2S sticks for a longer time. So you have to wash it maybe a couple of times to get the farting smell out of your clothing. So this is an evidence of this, because you have got this H2S. You will see more shift to the left means more H2S has to be reproduced to compensate to have reestablished this equilibrium. So more H2S smell, more H2S smell, correct? Because this is no smell, methane, natural gas, no methane. So the methane you smell, real methane has no smell. They put mercaptan, they put farting gas, so you can smell it. When there is a leak, we smell what? We smell the mercaptan, and they put a small amount of mercaptan or farting gas. So we can smell this natural gas, otherwise it's not smell. This one has no smell. Hydrogen has no smell. The only farting gas has a very bad smell. Whether it's a bird, animals, even maybe fish. Anytime you have a waste coming as a gas, you have carbon dioxide and you have H2S as part of digestion system. All the creation, except the trees, of course. The trees, that's the only exception. But all they have digestion system. They have to give you this H2S part of the process of digestion. So how about if you increase the pressure? Can I take this one out? Now we know the shift to the left, H2S is more, correct? So now, how about if I increase the pressure? So how can I get by this? All of them gases, so what I will do? If I have pressure or volume, I have to count what? Number of moles. This is 1 understood, not written, this is 2. So the sum of the moles here, what? 1 plus 2 makes what? 3. Here is the left product side is, the reactant side, 3 moles. How about here? 1 plus 4, how much? 5 moles. So 1 plus 4 is 5 moles. Now, if you increase the pressure, it means you are decrease the volume, and the shift will be to the least number of moles. Are you following me here? Increasing the pressure, increase the pressure, least number of moles. So will be where? To the left. Number of moles, 3 to the left. Shift to the left. Correct? What evidence? More H2S smell. Because I don't have anything to match the evidence except the smell of H2S will be this reaction. When you increase the pressure, you smell H2S more and more. Correct? How about increasing the temperature of the system? Well, we did not read the whole question. Let me go back. I just go back. We'll look if the reaction is, where is it? Oops, here it is, sorry. For the reaction, which change would be causing the shift to the right? Well, we did not put all the question there, but we're adding all this and see which one causing to the right. Correct? That's good. That's very good. So let me take those out. Where we are at now? Here it is. Okay. So temperature I cannot say because I don't know if it's endothermic or exothermic. Correct? And am I having any indication where the heat is? No. I don't know where the heat is. If it's in the left, it will be endothermic. If it's in the right, the product side will be exothermic. This one here, I will say the answer, my answer here will be non-applicable because I can't answer this question because I don't know. Why? No information about the heat. No information is given regarding the heat. So I don't know. So it's not given. So both of the A and B is to the left. The answer is which reaction will, which condition will affect the shift to the right? We'll check all of them. Increase the concentration of carbon disulfide. Carbon disulfide. Carbon disulfide is this one here. Carbon disulfide. If I increase the concentration of it, so meaning I am adding here, it is, take this one out. So I'm adding extra here, CS2 here, CS2. And the third, so this one will be what? Heavier or lighter? I'm adding what? I'm adding here, say, increase the concentration of carbon disulfide. Carbon disulfide is here, I'm increasing it. So this, I'm adding it to where? To the right, wherever is that the compound is found into. So this compound is in the right side, product side. So this one will be what? Heavier or smaller? I mean, heavier or lighter? Heavier, correct? Because I'm adding the same compound. This one will be heavier. This one will be lighter. So shift will be which way? Shift to what? No, this is because this is heavier because I added one compound that's already there. So this heavier will go down, correct? So in order to some of the weight has to get out from this heavy arm. The heavy arm has to be released in some of this. So shift to be to the left. What condition? More H2S because it has to go. Some of the weight here because it's added to this. This arm or this side will be very heavy because you added some extra of this. So it has to be shifted to the left and more H2S smell. Or odor, more H2S smell or odor is observed. So decrease the concentration of methane. Decrease of the concentration of methane. If I decrease this one here, if I'm removing a methane here out, where will be the shift? Where will be the shift? If I decrease, removing what? Removing methane out here. So this arm will be what? Lighter or heavier? Lighter, correct? So the shift will be which way? This one will be heavier. This one will be losing one of its. Shift will be which way? Shift to the left. And more H2S. Smell. It looks to us is none of those really none of those conditions will shift the reaction to the right. Which are those conditions from A to B to C to D? Which condition will add to this? So the answer is not there. So what will affect the shift from the left to the right? Not from the right to the left, from to the right. Well, which will action will be? Which condition we have to do? What type of conditions we have to add? Somebody will tell me. Which one? Two items we can affect shift to them. We can increase. This is A, B, C, D, F. This is F here. F. How about if I increase CH4? Increase. If I add here more H, this one will be heavier. The shift will be to the right. If I increase what? I increase the methane. If I increase this one here, A, B, C, D, E, F, G, H, E, F, G. If I increase H2S concentration, so I add H2S here, this arm will be heavier, shift will be to the right. So only those two conditions, increase the methane or increase the hydrogen dihydrogen sulfide concentrations, will affect shifting to the where? To the right. Are you following? So we did all of those here, but we did not see any of those here will shift the reaction to the right. Okay, guys? So let's do another one. This time I will not do the balance. You know the idea of the balance. Everybody has this? Now you help me with the, let me take this one out. And let's do, okay, so let's do, see, to the right, yes, none of them is really affecting, so, but we did the answer. Now, let's do it without looking at this answer. I'll put this one here on it. Answer without looking at multiple choices. What would be happen to the position of equilibrium when the following changes are made to the equilibrium system below? Yeah, that's a good one. If I add sulfur dioxide, this is dioxide here. Dioxide. Of course, sulfur, yeah. And this is sulfur here. Trioxide, sulfur trioxide. Now, visualize this in a piece of paper and think about the balance. I'm adding sulfur dioxide. Where sulfur dioxide will add to itself? To the left or to the right? Remember, this is my product side. This is my right. This is to the left, reactant side. So I'm adding extra of this. Where will be the shift? So if I add this one here, which arm will be stressed? The right or the left arm? Come on, guys. Which one? Because to the right. The right arm, no, the right arm will be stressed out because you added extra, and the shift will be the opposite side. Yeah, so the shift will be which way? Correct. I'm sorry, cool yourself down. Shift to the left. Don't be angry on me. So don't be angry on me. So just make sure that you understand the concept. Yeah, cool yourself down. Sulfur trioxide, that's the reactant. And I'm removing it. Not adding now, I'm removing it. Take this one out. So which arm will be heavier, which arm will be lighter of the balance? Yeah, the right will be heavier because the left one is losing, correct? So the shift will be which way? To the left. Both gases, they are really suffocating gases. I have one time sulfur dioxide, open it, and then it goes to sulfur trioxide. It goes very fast, and you cannot smell those. I mean, it's just, if you exposed to it for a long time, you'll not pass out, you'll die. You'll die, you'll pass away. So it's very, very dangerous gases, smelling very, very sticky, like something like in the throat, like the dagger. It eats up all the throat tissues. Anyway, so because they are producing in moisture here sulfuric acid. As soon as they are out, CO2 dioxide goes to trioxide, and then they are producing with the moisture. This is the from your car. The acid in your car is sulfuric acid. So those gases are concentrated. That's concentrated sulfuric acid will eat up all the tissues. So one time I was exposed to it. It was a leakage for my setup, so I just immediately turn off the hood down. So anyway, those are very nasty gases anyway. So they produce, when they come into the air, they produce sulfuric acid. So, and you heard about acid rain? That's part of the acid rain. Nitric acid and sulfuric acid, part of the acid rain. So now, oxygen is added. So sulfur dioxide is removed, shift to the left, correct? So oxygen is added to the system. I'm adding here more of this. Where will be the shift? So you add oxygen to the right, correct? The right will be heavier, more stress, more weight. So the shift will be which way? Yes. Now we are talking about very professional today. I'm lucky today is not a Monday, so this is good. So very good, very good. So let's do the third one. I want to cover all those until the end because I'm not going to chapter 9. I want to make sure that chapter 8 is understood because that will be a couple of questions in the ACS exam. Not one, more than one, maybe 2 or 3 questions about chapter 8. So let's take this one out. Everybody has it? Everybody has it? Let's take this one out. So let's do number 3. What would happen to the position of the equilibrium when the following changes are made to the reaction below? Now, you have mercury 2 oxide is decomposing, that's decomposition reaction, to mercury liquid and O2 gas. Now, if ion gas, that's a very good question. What is the K equilibrium for this reaction, guys? So I need an answer. What is the chemical equilibrium constant for this reaction? Come on, don't let me down. So this is liquid, not part of it. This is solid, not part of it. What will be? O2, that's it. Okay, guys? This is liquid, not part of the chemical equilibrium expression. That's solid, not part. This is the only thing. Okay, guys? You have to really to understand this. So if you get this one in the quiz or exam or the ACS exam, you know. Now, but when you add, that will have that's an effect when you add, but the equilibrium constant will not have because that's amount. So I will say this is, in some textbook, they said if you add a solid, there will be no effect because you don't add it to the equilibrium constant here. So I will add, since it's solid, I will say not applicable. Some textbook, but some textbook arguing oil, if you add too much of it, you might affect because it will add itself to the left. The shift will be which way? Shift will be which way? To the what? To the right. Now, some textbook will tell you this is not true because this is solid and we decided to have the K equilibrium. It's not affected by liquid and solid. So I will say that to be the safe side, say non-applicable. So will have no effect because solids and liquids, they have no effect on the addition on the chemical equilibrium because this is very important here. So if the pressure on the system increases, Now here it will have effect because you have to look at the number of moles. This is 2 moles, and this is what? 1 and 1, correct? So again, well, again, I will say let's do it this way. So shift not to the right, that's not applicable. So now let's look at this one here. Since we decided that liquid and solid is not applicable, so this one here, no shift, non-applicable, no shift because it's solid, correct? No shift. However, if you look, this one will not consider it, this one will not consider it. Number of this is 0 mole, we'll consider the number of mole, and this one here is 1. So if you add the pressure, the system will readjust itself to go to the least number of moles. Here I have 0 mole, and here I have 1 mole. So the least number of mole is the 0 mole. So the shift will be which way? To the left. Shift to the left. Now some textbook will tell you, no, we consider them, will not consider them in this. We consider them in the other side, when we consider the addition. Well, I said this is very confusing because you are not considering them inside the chemical equilibrium, and then you are considering them with the addition, and does not make any sense. You have to be consistent. If you are not considering them in this, then you should not consider them. They have any effect on the chemical equilibrium, because the chemical equilibrium at the end is controlled by this constant, the ratio between the reactants over the products raised to their corresponding number of moles, correct? So now C, I will add the C here, adding a catalyst. So what will be? Where is the shift? We said if add the catalyst has nothing to do with the chemical equilibrium. Chemical equilibrium has to do with the rate of the forward reaction equal the rate of the reverse reaction. Has nothing to do with the speeding catalyst, so no effect. This is the same token if you have add an inhibitor. Slowing the rate of the reaction has nothing to do with the chemical equilibrium. Chemical equilibrium is all about equalizing rate of forward reaction to produce product equal reverse rate of the reaction to produce the reactant back. That's what it says. Okay, guys? So catalyst and inhibitor, or catalyst or inhibitors, they have no effect on the chemical equilibrium. So let's do this one here. When the volume of the following, yeah, that's good because they have to have all of them gases. Not there is no liquid or solid. All of them gases, and then you can count. So here we are counting. Now we are mixture of gases increased, the volume. So we are talking the volume is up, correct? The pressure is down. In this case, when the pressure is down, to shift will be which way? Remember that, shift to higher number of moles. Correct? So if the volume is down, the pressure is up, this one here, to the least number of moles. Shift. Okay, guys, so now let's count with me here. Let's count with me. I have 4 here. I have 1 understood, not written. How many we have here? 5 moles. Here I have to, how many here? 4 moles. Now, I am increasing the volume. The volume is increased. I'm increasing, so the volume's up, this condition. So it will shift to the higher number of moles. Shift will be which way? To the left. Perfect. We are talking. To the left. Everybody's following? Shift will be to the left. So let's do number 5. Can I take this one out? Can I take this one out? Let's take this one out. Let's do number 5. Predict the effect of decreasing the volume. Now we are decreasing the volume. Let's go back. It's Boyle's law, gas Boyle's law. Whoever went to the last week extra credit, gas Boyle's law will have seen the experiment there. So we said if the volume is down, the pressure is up, correct? That's the opposite. When you decrease the volume, you increase what? Means you increase the pressure. The pressure will go up. So if the pressure is going up, always remember, the pressure is very important. Pressure is going up means it goes to the what? To the least number of moles. So let's calculate this one here. We have how many here? 3. Okay, in the back, be quiet please. 3 moles, correct? And here is what? 4 moles. Where is the shift? To the least number of moles, to the left. Here we have left. Now, again, here we have 2 gases. How many here? 3 moles. Correct? And here solid, we not consider the solid we have here. Even if you consider it, still 4. Correct? In this case, we have decreasing the volume, increase the pressure to the least number of mole. Where is that? To the right. Perfect. How about here? We have 1 and 1. That's 2 moles. And this is 1 mole, which will be to the least number of moles to the right. Okay, guys? So let's look at the heat now. Can I take this one out? Let's take this one out here. Number 6. So, predict the effect of decreasing the temperature on the position of the equilibrium. So, the heat here is in the right side. What does it mean? Please, your voice is here. Please. What will happen here if the heat in the right side? Is this exothermic or endothermic? The heat in the right side. This is the reactant. This is the product side. The heat is the product side. This is exo or endo? This is exothermic, guys. Anytime the heat in the right side, this is an exothermic reaction. If the heat is negative, whether it's in the right side, or negative value, means its heat is given away. So this is still what? Exothermic. Exothermic. The heat is positive, means you have to put in this amount. This is endothermic. So before solving those type of problems, you have to look where the heat is located and whether it's endothermic or exothermic. So you can understand that the value is not given to you. So here means the heat is here, correct? Here is the heat plus heat. This one here in the right side, this one in the left, and this one here in the plus heat in the right, because it's negative value. Okay, guys, so now what's the effect temperature on the position? Predict the effect of decreasing the temperature. Temperature will be down. Means we are cooling the system, cooling. Remember the ice we put those 2 test tubes? We are cooling the system in the experiment last week. So we are cooling the system, we are removing the heat by freezing the system, cooling the system. So meaning what? We are removing the heat. So the heat in the right side. So I'm taking the heat out. So which arm is more heavier? The left reactant side or the right is the product side? The product side is missing what? It's missing the heat, correct? So if it's missing the heat, so the right side will be missing some of its weight, if you visualize the whole thing weight. So the arm in the right side will be lighter, and in the left side will be heavier, because the arm, the right side, is had lost one of its component, the heat. So the shift will be which way? In A. If you remove something, you have to have something to come and compensate for whatever had been removed, correct? So shift will be which way? Come on, guys. To the right, because those has to react to compensate for this component, because you are recognize the heat as a component, correct? As a weight or a component. So now the heat is in the left in B. The heat is positive in the left, endothermic. So if you are removing the heat, which arm will be less, the left or the right? The left will be less, correct? The left side will be less, because you are removing the heat. So the shift will be which way? Those have to react to compensate for the heat lost. So shift will be the left. How about here? The heat in the right, correct? That's an exothermic reaction. And you're decreasing the heat, take the heat away. So this one here has to react to compensate for the whatever is lost. So shift will be to the right. Makes sense? It looks like with the heat, you are a little bit shaky, correct? A little bit shaky? Well, let's take another example here. Hold on. Okay, so let's take trying to get you good free worksheets. So it's nothing, you have not to pay for anything. So let's see here. That's yes, with the answer. I don't want with the answer, so I put without answer, but some of them they still bring you what answer. So those are, they need money. We need free without money, without answer. So yeah, we don't need. So we just keep looking until we get. Let's see this one. I don't know. It's okay. That's a good one. So let's increase this one here so we can see if we have the heat here. Okay, we have the heat, guys, correct? The heat is negative. Where is this? Is exothermic or endothermic? Now you tell me. This is exo or endo? Exo or endo? Anytime I have the heat in the right side or the heat negative, this is an exothermic. Anytime I have the heat at the left side or positive value, this is an endothermic in the left side. So this is, I heard the correct answer. This is exothermic, and it's located at, the heat is located at product side, products. Okay, guys, so this is the reaction here, and I will add here plus the heat, okay? So don't worry about the value. The negative is just, there is no energy or heat negative, but this one to designate it is left or right, okay? And there is the heat always positive, by the way, so make sure that you understand. So now we have anything about the heat. Let's do decreasing the volume. So here I have one, the number of moles is 2 moles, and here I have 1 mole. So decreasing the volume, meaning what? Increasing the pressure. So the pressure will go up. So it will be what? To the least number of moles. So shift will be where? To the left or the right? To the right. injecting more Cl2. I'm adding more Cl2. Where will be the shift? To the right. Why? I'm adding more of this plus more of Cl2. I'm adding more Cl2. So this one will be more stressed out, more overweight. So therefore, it has some of the weight has to be given to the other side, to the right. Okay, guys? Increasing the temperature. That's very good. The heat is where? The heat in the right side. If I increase the temperature, this arm will be what? Heavier because I'm adding extra component there, correct? The shift will be which way? To the left. Make sense, guys? Make sense? So removing BCl5, the products, I'm removing this one out. Will be where will be the shift? So the right arm, the product's arm, is missing one of its components. So this one will be lighter arm. The heavier arm will be at the left side. So where will be the shift? No, not to the left. To what? You are removing the products, correct? So you have to, some of the reactors have to react to compensate for the loss of the products. Increasing the volume of the pressure, meaning what? Meaning the volumes increase, the pressure will be down. It will go to the most number of moles. Where will be the shift? 2 moles is more than 1 mole. To the what? To the left. Addition of neon, an inert gas. Come on, guys. Addition of inert gas. What will be? Do we have neon somewhere? No. So will be Na, non-applicable, or no effect. Either or, non-applicable or no effect. Okay, guys? Let's look at the, can I take this one out? Take this one out? Okay. Everybody's confident now what's going on? A little bit? Comme ci, comme ça? 50-50? 50-50? Okay, so comme ci, comme ça. So, 50-50. So now, look at this. We did this one here. State 4 different ways to make more carbon react. We need to have more of this produced, correct? More react or four different ways to keep more react means to produce more products. That's what it's meant. Is a very awkward type of question. It's not telling them more react with what or what. So to make more carbon react. So meaning to produce more carbon react means you're producing the product more. So, but tell me how to do this. Is negative, so the heat will be which way? Reactants or product side? Negative, exothermic. Correct, so plus heat in the right side. So, if I let the carbon more react means I'm producing more product. So first, I have to go with number of moles. This is 2 moles here. And this is 1 mole. This is 1, this is 2. Okay, so what will happen if you will add more hydrogen to this one here? Add hydrogen. If I add the hydrogen, shift will be, meaning this one here, it's just very awkward to say to the students like this. Tell them the shift will be to the right. Shift, say to the right. We'll rephrase this reaction. More carbon reacting is meaning the shift to the producing more products. So what's conditions affecting the shift to the right? Well, we can do it together. So first of all, we say we can look at the product itself. So add more hydrogen. If you add more hydrogen, it will go where? To the other side, correct? If I add more, I have to remove methane. If the products, I remove it, the reaction will go to the right. So carbon will react. This is 2. What's the other condition? Now, I have 2 moles, 1 moles. If I increase the pressure, it will go to the side with the least number of moles. So increase the pressure. The condition, the other one, decrease the volume. So 4 conditions. Okay. Now, can I add another condition? Yes. I have the heat here exothermic, correct? I can remove heat, not adding heat. If I add, I want this one to the right, shift to the right here. So remove the heat. If I remove the heat, the shift will be to the right, correct? The heat is removed from the product side. So all those conditions, which are, let me just put them here, 1, 2, 3, 4, and 5. 5 conditions will affect the shift to the right. Okay, guys? So, this is the, don't worry, this is the, don't worry about it, don't worry about it. It's just, the monitor today is not happy. It looks like the lifespan of the pulp is coming to the end. Those are very expensive bulbs, special bulbs here. But I'll make a note that they will come and replace it. So, that's it, guys. Let's do another one. See if we can do another one. I'm not going to another chapter today. I can, but it's better to have this. Now, consider the equilibrium, this one here. Let's consider this one here, guys. Okay, guys? So, now, what will happen? I need the concentration. So, first of all, add the number of moles. Here is 3, correct? And here is what? 4. 4 moles and 3 moles. We'll make up our own questions. What will happen if you increase the pressure? Shift will which way? If you increase the pressure, the shift will be which way? Left or right? To the least number of moles, correct? Least number of moles to the left. Least number of moles. Okay. What will happen if you increase the volume? What will happen to increase the volume? Where will be the shift? Increasing the volume, decreasing the pressure will be to the most number of the moles, correct? Right? Most number of moles. We have 2 minutes. Cool yourself down now. Cool yourself down. We have. So now, what will happen if I will add more oxygen? Oxygen is added. What will happen? Where will be the shift? Added to the addition to the left, the shift will be the opposite side, correct? To the left, no. I added oxygen. Okay, so the addition to the left, then the shift will be the opposite of the addition. Will be where? To the left. I added H2O. H2O is added. Where will be the shift? I added H2O. I added to the right side, correct? H2O. The shift will be which way? To the left. Okay, guys? I removed NO is removed. I had removed NO. Shift will be which way? I removed one of the components in the right side. So the right side is missing something. So the shift will be which way? To the right. Don't let me down. Don't let me down. Just I'll close this one here now, the recording, and I will see you in the lab in a couple minutes.